Chapter 1. The Sweet Secret in Your Pantry. You've seen it in the supermarket, used it for desserts, coffee, and homemade recipes, but you've probably never wondered how that thick, creamy, sweet liquid gets into that iconic can. Condensed milk is one of those products we take for granted, a kitchen staple found worldwide that hides a fascinating manufacturing process far more complex than you might imagine. The story of condensed milk begins in the 19th century, long before modern refrigeration existed. In 1856, Gale Borden, an American inventor, patented the condensation process for milk. His motivation wasn't to create a dessert ingredient, but to solve a critical public health problem. In that era, fresh milk spoiled quickly, causing illness and death, especially among infants. Contaminated milk was one of the leading causes of infant mortality. Borden observed that if you removed water from milk and added sugar, the resulting product could last months or even years without refrigeration. Sugar acted as a natural preservative, inhibiting bacterial growth. During the American Civil War, condensed milk became an essential supply for troops, providing nutrition in conditions where fresh milk was impossible to maintain. After the war, the product gained popularity in civilian households. Today, condensed milk is a global phenomenon. In Latin America, it's indispensable for traditional sweets like dulce de leche, tres leches cake, and flan. In Asia, it's used in tea, coffee, and desserts. In Europe and North America, it's a baking staple. The most iconic brand, Nestlé's Eagle brand, is recognized worldwide by its distinctive red and white label. But what actually happens inside those factories? How is fresh milk transformed into that thick, sweet liquid? What secret ingredients does it contain besides milk and sugar? Is it really as simple as it seems, or are there complex industrial processes involved? In this video, we'll take you on a complete journey through the manufacturing process of condensed milk, from farm to table. You'll discover that creating this seemingly simple product requires sophisticated engineering, precise chemistry, and quality control that would surprise most consumers. By the end, you'll never look at that the same way again. Chapter 2. From farm to factory. Everything begins with fresh milk, but not just any milk will do. Condensed milk factories have extremely strict standards about the quality of milk they accept. The milk must come from healthy cows, be free of antibiotics and contaminants, and meet specific parameters for fat content, protein, and solids. Dairies that supply condensed milk manufacturers are regularly inspected, and their cows undergo rigorous veterinary checks. Milk is collected from dairy farms and transported in refrigerated tanker trucks at temperatures between 2 and 4 degrees Celsius to prevent bacterial growth. These trucks have monitoring systems that constantly record temperature during transport. Any deviation can result in complete rejection of the load. Upon arrival at the factory, each tanker truck undergoes an exhaustive inspection process. Milk samples are taken and analyzed in on-site laboratories. Technicians verify fat content, usually should be between 3% and 4%, proteins, lactose, presence of antibiotics, bacterial count, and somatic cells that indicate infections in cows. Only if the milk passes all these tests is it accepted for processing. Once accepted, the milk is unloaded into massive storage tanks, often with capacity for tens of thousands of liters. These tanks are equipped with refrigeration and agitation systems to keep the milk homogeneous and fresh. The milk doesn't remain stored for long. Processing typically begins within 24 hours of reception. The first step of processing is clarification. Milk passes through centrifuges that remove physical impurities, dirt particles, somatic cells, and any contaminants that may have entered during milking or transport. These centrifuges spin at thousands of revolutions per minute, using centrifugal force to separate denser materials from the liquid milk. Then comes fat content standardization. To ensure consistency in the final product, factories adjust the milk's fat content to the desired level. This is done through centrifugal separation that divides milk into cream and skim milk, which are then recombined in precise proportions to achieve the exact fat percentage required by the recipe. After standardization, the milk undergoes pasteurization, a heat treatment that kills harmful bacteria and enzymes that could cause spoilage. The milk is heated to approximately approximately 72–85 degrees Celsius for 15–20 seconds, then rapidly cooled. This ensures the milk is safe and stable before entering the concentration process. Chapter 3. The magic of evaporation. Now comes the process that defines condensed milk. Water evaporation. Fresh milk contains approximately 87% water. To create condensed milk, more than half of that water must be removed, concentrating the milk solids and creating that characteristic thick texture. But you can't simply boil milk in a giant pot. The process is much more sophisticated. The standardized milk enters multiple effect evaporators, impressive industrial machines that look like something from a science fiction movie. These evaporators operate under partial vacuum, which allows water to evaporate at much lower temperatures than normal. Instead of boiling at 100 degrees Celsius, as water normally would at atmospheric pressure, in vacuum conditions, water evaporates between 40 and 70 degrees Celsius. Why is this important? Because heating milk to high temperatures would destroy valuable proteins, cause excessive caramelization of sugars, and result in a product with a burnt flavor and dark color. Low temperature evaporation preserves the fresh milk flavor, keeps proteins intact, and produces a light, creamy color. The process occurs in several stages. Milk flows through a series of evaporation chambers, each operating at slightly different pressures and temperatures. At each stage, more water is removed. Water vapors generated in one chamber are used to heat the next chamber, an ingenious design that maximizes energy efficiency. This multiple effect system can reduce energy consumption by up to 80% compared to single effect evaporation. The walls of the evaporators are designed with special plates or tubes that maximize the surface area in contact with milk, accelerating heat transfer and evaporation. The milk flows constantly, never remaining static, which prevents it from sticking or burning. Mechanical agitation systems maintain uniform flow. After several hours of continuous evaporation, the milk has lost approximately 60% of its water content. What enters as 100 liters of fresh milk exits as approximately 40 liters of concentrated milk. At this point, the milk is thicker, but still not condensed milk. The defining and preserving ingredient is missing: sugar. The concentrated milk is carefully monitored throughout the evaporation process. Sensors track temperature, pressure, flow rate, and concentration levels. Operators adjust parameters in real time to ensure optimal evaporation without damaging the milk proteins or creating off flavors. Chapter 4. The sugar that changes everything. Sugar addition is what transforms evaporated milk into condensed milk, and it's not simply a matter of pouring in sugar and mixing. The amount, type, and timing of sugar addition are crucial for the final product. Typical condensed milk contains between 40% and 45% sugar in its final composition. This isn't just for sweetness. Sugar serves an essential function as a preservative. At this high concentration, sugar creates a hostile environment for bacteria and microorganisms. Sugar binds the available water in milk, leaving very little free water that microbes need to grow. This is the principle of osmotic preservation that allows condensed milk to last years without refrigeration when sealed. Sugar can be added at different stages of the process. Some manufacturers add it before evaporation, others after, and some use a combined method. Each approach has advantages. Adding sugar before evaporation helps prevent crystallization during heating, but can cause more caramelization. Adding it afterward allows better control, but requires more intense mixing. The type of sugar also matters. Most manufacturers use regular sucrose, cane, or beet sugar, but some add small amounts of glucose syrup to control crystallization. Sugar has a natural tendency to form crystals, and in condensed milk, this is undesirable. Consumers expect a smooth, creamy texture, not gritty. To prevent crystallization, manufacturers carefully control temperature and cooling rate. They may also add invert sugars, glucose and fructose, that interfere with sucrose crystal formation. Mixing sugar with concentrated milk occurs in mixing tanks with powerful industrial agitators. The mixture must be completely homogeneous, with no undissolved sugar lumps. The process can take between 30 minutes and several hours, depending on production scale. Temperature is maintained elevated during mixing to ensure all sugar dissolves completely. Once milk and sugar are completely mixed and homogeneous, the The product goes through a controlled cooling process. You can't simply let it cool in the air because rapid, uneven cooling would cause massive sugar crystallization, ruining the texture. Instead, condensed milk is gradually cooled in special heat exchangers that reduce temperature uniformly. During cooling, the mixture is continuously stirred to prevent crystal formation and ensure smooth texture. This is a delicate phase where precise temperature control makes the difference between silky, smooth condensed milk and grainy, crystallized product that would be rejected. Chapter 5. Quality Control and Packaging. Before condensed milk reaches the cans you know, it undergoes rigorous quality controls that ensure each batch meets strict standards for safety, flavor, texture, and composition. Factory laboratories analyze samples constantly throughout the production process. Technicians measure solids content, sugar percentage, viscosity, pH, and perform microbiological tests to confirm there's no bacterial contamination. A critical parameter is viscosity, measured with specialized instruments. Condensed milk must have the exact consistency, neither too liquid nor too thick. Viscosity affects how the product pours, how it mixes with other ingredients, and the overall consumer experience. If viscosity is off, the batch may be adjusted by adding small amounts of concentrated milk or sugar solution, or in extreme cases, reprocessed. Sensory testing is also crucial. Trained tasters sample condensed milk from each batch, evaluating flavor, sweetness, creaminess, and any off flavors that might indicate processing problems. They look for that perfect balance between sweetness and milk flavor that characterizes good condensed milk. Color is assessed using standardized color charts to ensure consistency. Once a batch passes all quality controls, packaging proceeds. Most condensed milk is packaged in metal cans, though versions in squeezable tubes and plastic bottles exist. Metal cans are the standard because they provide complete protection against light, air, and moisture, factors that could degrade the product. The canning process is highly automated. Empty cans arrive on conveyor belts, are filled with precise amounts of condensed milk by volumetric filling machines that measure exactly the correct quantity, and then are hermetically sealed. Sealing is critical. Any small leak would allow air and microorganisms to enter, spoiling the product. After sealing, cans undergo a sterilization process. Although high sugar concentration preserves condensed milk, many manufacturers apply additional heat treatment to guarantee absolute sterility. Sealed cans are heated in autoclaves at temperatures of 110–120 degrees Celsius for specific periods. This eliminates any resistant bacterial spores that might have survived the previous process. Finally, cans are labeled, packed into boxes, and ready for distribution. From this point, condensed milk can remain stable for years without refrigeration. Typical expiration dates are 1 to 2 years, but in reality, the product can last much longer if kept sealed. Some manufacturers include batch codes and production dates that allow traceability throughout the supply chain. Chapter 6. Secrets, Variations, and Hidden Truths. Now that you know the basic process, let's talk about some secrets and lesser-known truths about condensed milk that will probably surprise you. First, not all condensed milk contains only milk and sugar. Read labels carefully, and you'll find many brands add stabilizers, emulsifiers, and other additives. Carrageenan, an extract from seaweed, is frequently used as a thickener and stabilizer. Some manufacturers add sodium phosphate to improve texture. Others include